Hello everyone, I am Afshan Ahmed Khan and I am here to give a presentation on synchronization, thread communication and thread group. So number one, hybrid synchronization is whenever we have these two things. Number one, a shared resource, for example an object or some other type of data, and then there are multiple threads which are working on this shared resource. Then we have data consistency problem. So let me tell you about an example. Let me show you about an example. So here we have a class Ryan and Monica account. Now here number first we have a bank account. His bank account has balance 100 and it has two methods. Number one, a check balance method which just returns the balance, and second is withdrawal which just returns the which withdraws the given amount from the given balance from the balance. So it just subtracted the amount from the balance. Now moving forward, what we are doing here is we uh, we are making an object of Ryan and Monica account class. This Ryan and Monica account class implements the runnable interface, and in this class we have an account as we can see here, and it has two methods. The run, this is the method which we need to override. Here what we are doing, we are running this we are making withdrawal 8 times for each of the thread which it will create. Now as you can see, we are creating here two threads. So this loop will total run for about 16 times, and if we see here the balance is 100. So after the 10 time total number of if the threads run for total of 10 times, then we will don't have the enough balance. So in this make withdrawal function, what we are doing, we are making the we are calling account withdrawal method, and we are entering here only if the current balance in the account is greater than or equal to the amount. If this amount if the amount is less than this the account balance, then we will enter here in else, and we will say sorry, not enough balance for this thread. So what we expect is that when uh, when we will start his two of the thread, 1.start and 2.start, then this loop should run for 16 times, and after 10 times what should happen, we should get this sorry not enough balance. And here after the make withdrawal call, I am again checking if by chance this account the if the balance of this account if the balance of this account is equal to 0, and even then if you are making withdrawal, then we will get this money overdrawn. So if we run this, so if we run this, as you can see, so if you run this, we are getting money overdrawn, although the money should not be overdrawn, because we are checking here, we are ensuring that that we withdraw only if this amount is less than the balance of the account. So why we are overdrawing the money, this is because, so this, for example, suppose if a thread enter here, at the time which the thread enters here, at the time it might happen that the amount is less than the account balance, but at the same time this thread is going for sleeping for some time, and at that time if some other thread access also make withdrawal, then the amount will get decreased from what this thread thought that the balance originally was. So this is an example of data inconsistency, because between these two threads the data is not data is inconsistent. What thread 1 is thinking that the balance in the account is greater than this amount. So this was an example on data inconsistency problem. Now moving forward, we have concept of lock in Java. So every object in class has a lock associated with it. Now, how does this lock implemented in Java, and how we can explicitly grant an object a lock or a class a lock? We don't need to bother about it because Java internally manages lock mechanism. So suppose this is an object and it has a synchronized area. What is synchronized area I will explain later. And it does also having another area non-synchronized method. Then and if these two threads try to access the synchronized area, then the first thread which accesses this gets the lock of this area and will be able to call m1 or m2 method on this. But at the same time, if a thread t2 tries to access this area, then it won't have lock as it is currently uh, in possession of thread t1. So after this thread T1 has done its work and releases the lock, only then the thread T2 can have the lock and it can call M1 and M2 method here. While on the non-synchronized area, all the threads can call simultaneously M3, M4 or M5. So ways to do synchronization. There are two ways. Number one, mutually exclusive. Here what we do, if a thread is doing synchronization, then only a thread at a time can access synchronized area. While in inter-thread communication, what we do, thread communicate with one another to manage the log. Until mutually exclusive, we have a synchronized method to make a method synchronized block to make a block of code synchronized, and static synchronization. So synchronized method, only threads having lock of an object can execute this method. So its syntax is access modifiers. What syntax main is, we have synchronized keyword in the method. So for example, suppose if we want to solve this problem, then we can make this method synchronized. So if I run it again, then I will now don't have money overdrawn error as money overdrawn message as earlier I was having, because only at the time only one thread has access to this make withdrawal function because it is synchronized. Moving forward, we have synchronized block. Now see what the synchronized method does. It makes the whole method synchronized and it makes our program slow as only at a time only one thread can access our method. But if there are just some lines of code which need synchronization, then we can add those line in this block. So its syntax is synchronized, and then the object reference expression, for example, it means the object whose lock the thread should have for running this code block. In bracket we specify the object whose lock the thread should have for running this code block. And the second, so the number one point here is only threads having lock of an object can execute the contents of this block as before, the same as before. Scope of synchronization block is smaller than the method because we declare here, we don't declare whole method is synchronized here, just declare some lines of code is synchronized. So for example, instead of declaring the whole method is synchronized, what I can do, now what does this tell? That the thread which is having the lock of this object means Ryan and the object of Ryan and Monica account class. So if I run it again, I again will not get money overdrawn message. Moving forward, we have static synchronization. Now if any class is having static method, now static method are class level method, and if we make it static method synchronized, then the object will need to have, then the thread will need to have class level lock. Other method is inter-thread communication. So the two threads can communicate to each another by using wait, notify all. What the thread expecting updation calls wait method. So let me tell you an example. So here we have a main thread. Now what we are doing here, we are making an object of we are making an object of thread b class. So here it is thread b class. It has a total variable integer, and we are starting this thread. In this run method, what we are doing, we are running this loop for 100 times, and each time we are adding the value of I into this total variable. So what the problem here is that it might happen if we don't use b.wait here, then this main thread will not wait for updation of this total variable, and we may have in wrong answer for this total variable. So for this we call b.wait, so that now the main thread will wait till till the object notifies the main thread. So how we notify? We, since the main thread calling wait on the object of thread b class, so when we call this dot notify, then it will notify all the object, all the threads which call the wait on this class. So as now you have seen how the inter-thread communication works. So now we have, we were reading here the thread expecting updation called the wait method. As we have seen earlier, the thread responsible for doing updation, as we can see, the thread responsible for doing updation, the thread responsible for doing updation calls notify. Yes, here it is another thread, thread B. This is expected to do updation of this total variable, so it is calling this dot notify. The thread calling wait method releases the lock of the object. Unlike sleep method, the prototype of wait method is public final wait. This is the normal wait. What I want to notice is that all these three of method throws interrupted exception. These throw methods will wait for some millisecond, and they may come out of waiting state out when either when the timeout occur, or when someone some other thread notifies this waiting thread. Notify all have the prototype as public final notify, public final void notify all. Now notify versus notify all. Notify gives notification to single waiting thread. Other thread keep on waiting, or we have to call notify again to notify other single waiting thread. So what this means that notify just notify a single waiting thread. If we want to notify other waiting thread, then we have to again call notify. While the notify all, it notifies all the waiting thread at the same time. Now thread group in Java. We use thread group in Java to group multiple threads as a single object. For example, suppose we need to call suspend, resume, or interrupt method, or some other method on a thread. Then we don't need to call explicitly on each of the threads. We just group them in thread group and call the method on the group. It will get called on each of the thread. Thread group can be created with thread group, and it's, in the creation function and in the constructor we pass as a string the name of the thread group. Thread group can include other thread group as its parent by calling thread group parent thread group, and the name of the and here the name is the name of the thread group which we are creating. So these are some of the methods of thread group. And active count, it just returns a number of active running threads available in a given thread group. And active group count, this method returns the number of active thread groups running. Destroy, this method destroys the thread group and its subgroup if available. And enumerate, call to this method puts the thread available in invoking thread group into the group array of threads. And enumerate, call to this method puts the thread available in invoking thread group into the group array of threads. If the recursive flag is true, then threads in subgroups are also added to the group of array. And enumerate, this method puts the subgroup of the invoking thread group into the thread group array. This method puts the subgroups of the invoking thread group into the thread group array. If the recursive flag is set true, then all the subgroups of the subgroups are added to the group array. So let me tell you about an example. for this thread group. So here in main method we are creating a thread group of name my thread group and storing it in a variable grp. So we can create new thread group by what we are doing here. We are making an object of my thread extends this thread class, and in constructor what we are taking the name of the thread which we want to create in the thread group in which this thread should lie. So because we then calling the constructor of the its parent class, which is thread class. This class takes a constructor, a thread group, and the name of the thread which we want to create. So after making these two threads T1 and T2 of name thread1 thread2 lying in the group grp, we then print starting thread T1 and T2 and then start. Then we calculate the number of active thread by calling the group grp.active count. It returns the number of active thread. We then interrupt. Let me run this. So if we run this, so if we run this, we have number of active threads stored. It's T1 and T2. Now what we are after starting, what happened? This run method will get called. Then this loop will start to run for 10 iteration. In each iteration, it will print the name of the thread and the value of the I in that iteration, and will then send the thread to sleep for 10 milliseconds. So after starting, we printed active count as we can see here. Then we interrupt the thread, and when we interrupt the thread, we will get interrupted exception. So as we can see, exception encountered because we call interrupt on this group. Then both of these two threads get interrupted. Then we make t1.join, t2.join because we want to destroy both of these threads. So we wait till these two threads complete, and once these two threads complete, we then destroy by calling grp.destroy and message the message and print a message destroyed thread plus the name of the thread group which we destroyed. So thank you.